All right, geometry guys, we are halfway through this last section. Here's the beginning of this 5.3 talking about similar triangles. All right, similar triangles, they're specific because we actually have to use a postulate and a couple theorems to figure out if two triangles are actually similar. This is going to be somewhat like the unit on triangle congruence, except we probably won't be dabbling too much into proofs. It's more going to be recognizing that, yeah, these two triangles are congruent by side, 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 or these triangles were congruent by angle, side, angle, or something like that. Except now we're dealing with similarity. All right, so one of the easier ones for similarity is just saying two angles are congruent. Two angles of one triangle are congruent to two angles of another triangle. The triangles are at least similar. All right, so this is called angle, angle, sometimes called angle, angle, angle. But if you think about it, if these two are congruent and these two are congruent, shouldn't these have to be congruent because every triangle's got to add up to 180? It's like if this is 40 and this is 50, that makes this 40 and this 50. Both of these have got to be 90. I'm just using this for argument's sake because they both have to add up to 180. So if angle A is congruent to angle F and angle B is congruent to angle G, then I can say, yeah, ABC is similar to FGH. Again, I'm not using congruence. I'm using similar. Don't put the congruent symbol in there, otherwise you'll get it marked wrong because they're not congruent. They're similar. It's totally different. So 57, 48, 57, 75. So I know at least these two are congruent. So let's see what this last one might be and see if there's a possibility that these two are going to be congruent. Well, if one's 57 and one's 75, 180 minus 75 minus 57 will yield you 48. So that matches up to that. So yeah, those two are going to be similar. My similarity statement will just look like this. JLK, similar to triangle QMP by angle, angle. Sorry, that's a P. Here's one that will haunt you because they don't actually give you any angle measurements. But there's a couple things you can always do with angles. First off, those two are going to be congruent. Well, how do I know that? Well, they're vertical angles. If these two are parallel, and I allow this to be my transversal, couldn't I not argue that those two would be congruent because they are alternate interior angles? And the answer to that question is absolutely, Mr. Heeren. That is exactly what you should do. I know. Thank you. Anyway, so those two are congruent. Those two are congruent. That is way enough to say, yes, XRS similar to TWS by angle, angle. That's all you need to say. Now, side, side, side. This is different than side, side, side for congruence. It's going to be completely proportional. So if I say JL over MQ is congruent to JK over MP is congruent to QP over LK, then my triangles are similar. One big change that you're going to notice, and this is kind of just a general overall, kind of taking a big picture. When you're talking about triangle congruence, you love side, side, side because it meant you didn't have to deal with any angles. You didn't have to figure out any angles. You love side, side, side because it was easy. When you're talking about similarity, you almost want angles and angles only because those are easy. Sides get tougher because you've got to show that they're in proportion. You've got to show that they all come up with the same thing. So if I'm looking at this one, I've got to look at, does this match up? So well, how would you do it? I mean, you would obviously take 9 over 6, but would you take 6 over 4 or 6 over 5? I think you would take 6 over 4, and I think you would take 7.5 over 5. This becomes 3 over 2. This becomes 3 over 2. 7.5 over 5 also becomes 3 over 2. So yeah, those are similar because of side, side, side. So I say triangle ABC is similar, not congruent. I know I will catch somebody on that. So ABC, we better go D, E, C by side, side, side. But notice, I had to show that all three of those sides are similar. Don't worry about proof. I don't think we'll get into that. Proof of similarity gets kind of tricky. So one final piece, side, angle, side. Now, it's different than congruence. You have to show that the two angles are congruent. Oops, sorry. I want this one. Angle S and angle Y. And you've got to show that the two sides are in proportion. So SR and YX. And you've also got to show ST and YZ. Please also notice that is the angle being made by the two sides. It is the angle that is included. Included. It's not one of the other angles. So if I say triangle RST, I better say triangle XYZ for similarity. So determine whether or not these two would be similar. If so, write a similarity statement and explain your reasoning. Ha! So let's look at the letter A. So here's what I know for sure. I know those two are congruent because they're vertical angles. They always are. Now, if I match up 10 and 22 and 11 and 20, that doesn't work. But if I go 10 to 20 and 11 to 22, that does work. It's like I took the triangle and twisted it and made it smaller. So 10 over 20 works, and 11 over 22, those are going to be equal. Also, these angles are going to be equal. So I'm going to say, yeah, but here's how I got to say it. If I got to say X, Y, W, then X, Y, W, then I've got to say Z, T, W. Okay, because this corner matches up with this corner matches up with this corner. All right, so that's going to be triangle Z, T, W by side, angle, side. Okay, letter B is one that kids get confused a lot. There's actually two triangles here. There's the little one and then the big one. So if I just look at the little one, first off, M is part of both triangles. So here's what everybody does. Everyone starts looking, oh, it's 10 over 15 and that's 12 over 18. Oop. Absolutely not. It is absolutely not. You do use 10, that is correct. But you use 10 over the whole thing because you're comparing it to the big triangle. So it's 10 over 25, and this is going to be 12 over 30. So this is going to be 0.4. This is also going to be 0.4. M is the angle shared, so it's part of both triangles. And it's also the included angle. So I'd say yes, triangle MNP, similar to triangle MRS by side, angle, side. But please notice, M is part of both triangles, and it's like I laid one on top of the other. So in this figure, ADB is a right angle. Okay, cool. Which of the following would not be sufficient to prove that ADB is similar to CDB? So you're trying to prove this big one is similar to this little one. Well, this is a right triangle. That's got to be a right triangle. I got to know something else, though. So let's look. AD over BD. So if I can show that these two are similar, and then BD over CD, so then this one and this one, that would actually work. Okay, because here's what I'd show. I'd show AD and BD, so this part of this triangle and this part of this triangle are similar, but then I can also show that this part and this part are similar. That's a very, very tough one to see, but that's all I would need. That one would work. C is going to work because that just doubles up my angles. So which one does not work? AB and BC. That one's fine, it's true. And then BD and CD. That's fine. Okay, that's nice to know, but it's not enough because remember what I've got. I've got side, 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 angle, side, or angle, angle. This tells me, again, this is like angle, side. This is like side, side, angle with this one. All right, that's going to be side-side angle. So that one doesn't work at all. So B is going to be the one that would not be sufficient to prove. All right, A is good, C is good, D is good. D's got all three of them, so that's fine. So that's not going to work. We're back to parallel. We're back to parallel. Parallel tells me, you know what, matches up with this. This one matches up with this one. You know they're similar, but here's kind of how it matches up. 4 over 10 is going to be equal to x plus 3 over 2x plus 10. So a little equal 4, 2x plus 10. So that's going to be 10x plus 30, 8x plus 40. Little algebra. 2x equals 10. So x is going to equal 5. Here's another one, probably about the last one. So we've got 250, 60, 40. So this is parallel, so we know that they're similar. Find the length of the lake. Well, here's kind of how it works. 50 over 200 is going to be equal to 40 over the length of the lake. So this simplifies to nothing more than 1/4. So the lake is going to be nothing more than 160 meters. That's all I got. Watch this over once or twice and see if you got questions. Otherwise, I look forward to talking to you in class and helping you get this figured out. Have a good day.